All right, these are the solutions to the shopping cart question. So you have 9 shopping carts and they're frictionless. And you know the acceleration of every single cart is 0.052 meters per second squared. And you know that each cart has a mass of 27 kilograms. Okay, so question A says, determine the force that the employee exerts on cart number 1. So the reason I love this question is that it really helps you think about what you can grab any number of objects that are connected to each other and define that as your system, right? So you can't say that you want 1 and 9 to be your system, but you could say 1 and 2 together are what you're looking at, 1 through 3, 3, 4, 5, whatever you know, you can grab any combination of things that are already right next to each other. So I color coded all the internal forces. So the employee only touches this cart. But cart number 1 slams into cart number 2 because cart number 2 has inertia and wants to stay at whatever speed it's going. 2 slams into 3, 3 slams into 4. But all of these forces are internal. So I drew 2 of them. Each one of these is an action-reaction pair. So if we define all 9 carts as our system, then those all cancel. And then we can find the external force. So we're defining all 9 carts as a system. All of the normals are internal. So the only force we care about is the one we don't know. Okay, and then look, grading some people's work, they forgot to multiply by 9. There are 9 carts. Each cart is 27 kilograms, and each cart has an acceleration of 0.052. And that yields a force of 12.64 newtons. So we now know that this force here is 12.64 newtons. That force informed the acceleration. So if the acceleration were bigger, that force would be bigger. Okay, and then each normal force, like this green normal, it's responsible for accelerating everything in front of it. So this is a little bit less than 12.64. This is a little bit less than the green one. This light green one is a little bit less than the purple one. Each of these normal force decreases because each subsequent normal is only responsible for accelerating what's in front of it. So you could go down the line. You could isolate shopping cart 1, and you now know that the force on it from the person is 12.64. You know the it is running into electron clouds of shopping cart 2. So this is the normal between 1 and 2. You could say sigma F equals MA, and we have the 12.64 minus the normal between 1 and 2 equals only 27 kilograms because I'm isolating 1 cart times the acceleration, which is 0.052. And you get the normal between 1 and 2 is, you get that the normal between carts 1 and 2 is 11.24. Which is less than the 12.64. Otherwise, cart number 1 would not accelerate. Like, it needs a net force to the right because it's accelerating to the right. All right, and then you could look at cart 2 and say 11.24 minus the normal between 2 and 3 equals MA. And you could work your way all the way down the line. But that would be maybe interesting, but a little bit tedious, right? So if we want the normal force between the 6th and the 7th cart, then let's be lazy, clever, and attractive and figure out, oops, sorry, that was supposed to be an eraser, figure out what we want to isolate. Okay, so clean this up a little bit. We want to know how much pressure is there between the 6th and the 7th cart. We want that normal right there. So we have 2 options. You could say my system is carts 7, 8, and 9, and that way this blue normal is the only outside force, right? Cart number 6 is no longer part of your system. So it is pushing on carts 7. And so if we define these 3 things as our system, I think that's what I did. Let's go down and see. Then the normal between cart 6 and 7 equals the mass of my system times the acceleration. Okay, and we grabbed 3 carts, so the mass is 3 times 27, and everything in the system is accelerating at that rate. And you get the normal is 4.212 newtons. Okay, you could also grab carts 1 through 6, and then the normal from between cart 6 and 7 is an outside force because cart 7 is not part of your system. And then we would know that what we get, 12.64 is an outside force because the person's not part of the system. And this is what we want to know. So and it's accelerating at 0.052. So the 12.64 pushing on all of these to the right minus the pushback from cart 7 equals, I have 6 carts and every cart is accelerating at 0.052. So then that means the normal between 6 and 7 is 12.64 minus 6 times 27 times 0.052 is minus 8.424, which is 4.216. And that should be the same as what we got. Yeah, more or less. So that's why I really like this question, is because it really helps you realize you can be flexible about whatever you grab and define that as your system, right? Okay, I'm going to say one last thing, and you can clearly stop the video if you don't want to think about this. The common mistake people make is they want to, so this occurs on the rest of the limiting values worksheet. Let's say this is 6 kilograms and 4 kilograms, and you push on it and it's frictionless, and you push on it with a force of, let's say, 30 newtons. Okay, so clearly the acceleration of this system is going to be 30 newtons over 10 kilograms, or 3 meters per second squared. To find the pressure that, like, the 6 literally runs into, it's being pushed into the 4 kilogram. You need to isolate either the 6 or the 4. If you isolate the 4, this is what I sometimes see people do. People know that that 4 is indirectly being affected by that 30 newtons. But if this is me, Miss Groppy, pushing on Mr. Jai in the lunch line because I'm like, I'm hungry, I want to have food, and then Mr. Jai is pushing on Mr. Fernley, all Mr. Fernley knows is that Mr. Jai is pushing on him. He doesn't know that that is happening because I am pushing on Mr. Jai. Okay, so the only thing the 4 kilogram block is in contact with are the electron clouds from the 6 kilogram. So there is a normal between these two, and that's the only force on the 4. So if you want to find the normal between the two blocks, then the normal on the 4 equals 4 kilograms times its acceleration, which is 12 newtons. And that should make sense because if you just look at the 6 kilogram, it's got 30 newtons pushing it to the right, and 12 newtons pushing it to the left, and 30 is bigger than 12. So it's clearly accelerating to the right. And then you could check your work that the acceleration of the 6 is going to be 30 minus 12 over 6, which is 18 over 6, or 3 meters per second squared. Yay. Okay, so good question, and a good way to really help you remember how to isolate, be smart about which objects you isolate. That is it. See you in class.